Hello, welcome. Let's continue to solve a still game problem. So Leetcode 1406, still game 3. So for this problem, let's first try to understand the question. So the problem is for Alice and Bob, gonna choose from the left side. So for each turn, Alice or Bob can take from 1 to 3 stills. Yeah, from 1 to 3 piles. So Alice and Bob will take the stills optimally. So this is a game theory problem. Normally we're going to solve it by using dynamic programming, but here I'm going to use the DFS plus memorization. And for the DFS part, I'm going to define a function for the maximum number of stills Alice can take. So this is going to be my DFS. And basically, Alice and Bob will play this game with each other, and Alice will play optimally, and Bob will play optimally. As I've defined, my function is for the maximum stills Alice can take. So Alice will choose always to be the maximum value of the possible result. And for Bob also wants to do this, but in my DFS function, I can only define for one of them. I cannot define Bob as well. So while it goes to the Bob's turn, Bob will actually give something to Alice. So Bob will give the minimum value of the possible result. And Alice will choose the maximum of the possible result. So this is going to be the final return. And for the Bob, while giving the minimum value, it's going to be the left behind, because definitely Bob will also choose something. And what Bob returns is going to be the left behind value. What left behind value, and those values are going to be the minimum. Yeah, if you understand the principle of the game theory, now we can use this principle to solve the problem. Yeah. So I'm gonna define a DFS function. So I'm gonna start from the index 0. So this means just from the beginning. I'm gonna define a variable Alice. This means Alice will start first. So if this I is more than and equal to n, I will go out of the boundary. Now let me try to define what is this n. N is for the length of the still value, and my result I'm gonna call this DFS. It's gonna be from 0 and true. This true means Alice will start first. So finally, I'm gonna check this result with my total value. So the total gonna be the sum of the still value. So if this result more than total minus the result, it means Bob. If Alice value more than Bob, so I'm gonna return Alice. So this is just according to the description. So Alice result is less than total minus the result. So I'm gonna return a Bob. Otherwise, I'm gonna return a tie. Yeah. Now I just need to finish the DFS part. And the DFS part is not so difficult if we understand the game theory, and if you solve the still game 1 or still game 2, basically it is similar to still game 2, and it is a little bit easier compared with still game 2. I mean, it is easier than still game 2, because still game 2 basically we need a lot of mathematical calculation, but here we don't need that because we can only choose 1, 2, 3. Yeah. Now, similarly, we're going to define a result, and it's going to be the negative infinity if this term is for Alice. Otherwise, I'm going to define a positive infinity. Now, I'm going to check if this term is for Alice. So I'm going to decide how many stills Alice can take. So I'm going to define another variable j. So for j in range from I to I plus 3, because I can take 3 maximally, and I need to take at least 1. So the result gonna be the maximum of all the possible results. So it's gonna be the DFS j plus 1, but I need to sum the how many stills I can take. So it's gonna be the still value from I to j plus 1. Let's just use an example. So if this I is 0 from the beginning, and this j, if this j choose to be I plus 2, so it's gonna be 2 for this j, and how many stills? It is 0 to 3. So in Python, normally it means the first 3 stills. 0 to 3, it means 0, 1, 2 index. So it means the first 3 stills. It means the result is right. Yeah. Now we're gonna check if it is for Bob. Yeah, let me just copy it. Yep. I put something inside the DFS, but I didn't put a boolean value for the Bob, so I'm gonna give a false to Bob, and here I'm gonna give a true for Alice. And here I needed to use the minimum because Bob will give something to Alice and it's gonna be the minimum, and Bob will not give something taken by Bob because this sum is taken by Bob. Bob will not give it. Bob only give what left behind to Bob, to Alice, and Alice will decide to take the maximum value. This is from here. Yeah. Basically how the function runs. The function will run from here. So this first term is Alice. Alice wants to get something and wants to get the maximum of it. But here inside there is a DFS for Bob. And this DFS for Bob will give in something to Alice, but it's gonna give the smallest value, the minimum value. But then Alice can decide to choose all combinations, can choose the biggest, the maximum value, and this is gonna be the final return. Yeah, so this is gonna be the entire code. As you can see, it is not so difficult. Now let me just run it to check. I'm missing some variables for the DFS. Yeah, I forgot to put it. I need to put it inside of the DFS. I put it outside, I believe. I just put it wrong. I should check it carefully. Yeah, I should put it inside. Now let me run it. As you can see, it works. Now let me submit it to check if it can pass. Yeah, as you can see it passed, but the time is really slow. So that is because for one thing, let's analyze the time complexity first. So the length of the array is 5 times 10 to the power of 4. So for I, this is going to be n. n is 5 times 10 to the power of 4. And for Alice, it's going to be true or false, it times 2. So 10 to the power of 5. And here inside, did we use anything for loop? Even we use the for loop, but there's only 3 values, so we will ignore that. And we also use the sub, it's going to be 3 values, so it's going to be 3 times 3, it's going to be 9. So 9 going to be maybe 10. 10 times 10 to the power of 5, so it's going to be 10 to the power of 6 for the time complexity. So normally it should be okay. Why it is so slow? That is because in Python, if we use all other languages, if we use the DFS recursive function, definitely it's going to be much slower. And that is because we use the cas, and cas is especially slow for Python. That is why it is so slow. But I think it doesn't matter because we just need to analyze the time complexity. If we change it to another language, maybe it is much faster. And the next step to learn is that we're gonna learn it to how to turn this kind of code to be a tabulation. So that's gonna be the real dynamic programming, and that will be much harder to learn, but definitely it's gonna be faster. Thank you for watching. See you next time.